Okay, so as in the last video we have derived the formula for calculating the velocity of an electron. In today's video we're gonna derive the formula for calculating the energy of an orbit, right? And that was also included in the Niels Bohr's atomic model postulate, because he has calculated or derived the formula for calculating the energy of the orbit, right? Now we know that if electron is revolving in an orbit, for suppose this electron is revolving in an orbit, right? We know that it is revolving, and we know that due to the motion of a body, which energy is produced in the body, that is kinetic energy, right? Wait, let me write that is kinetic energy. Means this electron has kinetic energy. This electron has kinetic energy. And if two charges are put here, right, we know that this is nucleus, and nucleus has what? It has positive charge. So there would be a potential energy as well between these two charges of radius r, right? This is the first charge q1, and this is another charge q2. Between them there is a distance which is r, which is radius. So there is potential energy as well, and that energy is known as electropotential energy. Right? Let me write that. Electropotential energy, right? So there is a electropotential energy plus kinetic energy in the orbit of an atom, right? Today we're going to derive the formula for calculating the kinetic energy of an orbit, right? So we know that what's the formula for finding the kinetic energy, that we know very well, right? Because kinetic energy is equal to half mv square, that we know, right? Half mv square. Now we have already derived the formula for velocity, right? Here you guys can see we have already derived the formula for velocity, and that is equal to ze square upon 2h epsilon naught n. So we need to put this formula or put the value of velocity in this, right? So let me write here this statement. Putting the value of velocity in kinetic energy formula, right? In kinetic energy formula. So let me highlight this now. Okay, I've got this color. Now we're gonna put the value of velocity instead of v in the kinetic energy formula, right? Now we know that kinetic energy Ke is equal to 1 upon 2, m will remain same. Instead of v we need to put the value, right? And that is equal to ze square upon 2h epsilon naught n. Now do not get confused, because we have already derived the formula for finding the velocity, and here you guys can see we have derived this formula by using mvr is equal to nh by 2 pi, which means angular momentum is equal to the integral multiple of h by 2 pi. There we substituted the value of r, which is equal to n square h square epsilon naught upon pi m ze square, and hence we got our formula for finding the velocity, that was equal to ze square upon 2h epsilon naught n. So we have replaced that value instead of v here, right? Now as you can see, up to the v we have a square, so we need to take the square of this entire value, right? Now let me highlight this. Okay, so now let's take the square of this. if I'm going to take the square of this, z square e 2 2s are 4, right? So e power 4 upon 2 2s are 4 h square epsilon naught square and n square, right? N square, that we know. So k e is equal to, now let's multiply this, right? Up we'll have z square e power 4 m upon down 2 4s are 8 h square epsilon naught square n square. Now the same trick we need to follow. We need to separate the constants, right? We need to separate the constants, and we need to separate the values which will be gonna change, right? So wait, let me highlight till this. Now we're gonna separate the constants. So let me write that. Separating the constants, right? Constants. By separating the constants we get, wait, what did we get? This does not look good at all. Alright, let me erase this. Let me make this with red one. Okay, so let's separate the constants. Now we know that here we have z square will gonna be changed, right? Because atomic number of every atom is not same. For example, hydrogen atomic number is 1, however helium atomic number is 2. So z square will gonna be changed, right? So z square is not a constant. However, charge of an electron is constant, and we have mass of an electron is constant, right? Upon 8 is constant, h square Planck's constant is constant, that is equal to 6.625 into 10 to the power minus 34 joules, right? Epsilon naught is constant, epsilon naught square is constant because its value is 8.85 into 10 to the power minus 12, right? And n square is again not constant, since the number of shell or the shell number will gonna be changed, right? So into z square was not constant, and down n square was not constant, and that is for, wait, that is for kinetic energy, right? Kinetic energy. Let me highlight this so that we can go ahead. Now here we're gonna get one more value for this entire constant. This entire constant is equal to 13.6. This entire constant is equal to 13.6. Remember this thing, I am calculating the kinetic energy of orbit in the electron volt. I am gonna guys drive the formula for finding the kinetic energy in the kilojoule per mole as well, but for now this is in the electron volt, right? Into z square upon n square. So this is the shortcut. This is the shortcut for finding the kinetic energy of an orbit in a particular atom, right? Here we got a shortcut. Now for suppose if you are giving something in the kilojoule per mole, if you want to find the value of kinetic energy in the kilojoule per mole, then this whole constant value will gonna be equal to the 2.178 into 10 to the power minus 8 joules. That would be equal to, or I should directly write the the constant value, and that is equal to 1313.135 into z square upon n square. Only the constant value will be changed, right? And that is kinetic energy in the kilojoule per mole. Kilojoule per mole, and that was in the electron volt. that was in the electron volt, and this is in the kilojoule per mole. Right, so this was all about kinetic energy, how we're gonna find the kinetic energy of an orbit. I have guys derived the formula for you, as well as I have told you the shortcut as well. In the next video we're going to discuss about, or we're going to derive the formula for finding the potential energy.